China's doing something strange. It's bringing burrowing animals straight into the desert. Why? No one really knows yet. Along the Great Green Wall stretch thousands of miles of plantations. It's supposed to be a barrier to stop the Gobi Desert. Billions of trees, decades of work, all to keep the country from turning into a desert. But there's a detail people rarely talk about. Under those trees, there's almost no life. The soil is dense, dry, it doesn't hold water, the tree roots can't grow deep. And it's exactly here in the driest areas that China wants to release animals. A lot of them. They'll be set free right among the young trees. And that's just the beginning. In the coming years, there will be even more of these animals here. Why exactly are they being sent into the desert? And what's supposed to happen there? Let's find out. Let them dig the place up. An unobtrusive reminder to do that thing under the video. Let's jump ahead right away. The place where the animals were brought is an anomaly. It shouldn't have existed in nature. This forest seems endless, a green wall stretching up into the sky. But lift your eyes, and there, just beyond the last line of trees, sand dunes are already rising. The contrast is so sharp it feels like someone split the world in two. On one side, life. On the other, a scorched desert. If you look closely, the forest behaves strangely. All the trees are identical, standing in perfect rows, as if someone copied one model and pasted it thousands of times. Between them is emptiness. No grass, no insects, no birds. The air doesn't move. Everything is still. The forest exists, but the ecosystem doesn't work. And that's no accident. Every tree here was planted by humans. It's part of the largest greening experiment in history. Our little creatures ended up inside a system that could never have formed on its own. To understand how it appeared, we have to go back a few decades, to where it all began. Northern China is a place where nature gives no mercy. Rain is rare, the ground cracks open, and the wind blows away anything that fails to take root. The mountains in the south trap all the moisture behind their rocks, and it never reaches here. Everything alive lives on the edge. One season without wind and the soil turns to dust. That's how deserts are born, vast, hungry zones that know no borders. They move slowly, but never stop, claiming new patches of land year after year. When it became clear that the sand couldn't be stopped, China decided to step in and change the system itself. In 1978, they started building not walls, but a line of trees stretching nearly 3,100 miles, right where the desert was already encroaching on cities and farms. It was meant to become a living barrier that would hold back the advance of the Gobi. That's how the Great Green Wall appeared, a copy of the ancient structure, but this time aimed not against people, but against nature itself. Over 46 years, China planted billions of trees and claimed the desert was finally contained. Millions of seeds were dropped straight from airplanes, and millions more saplings were planted by hand in almost every region where the desert tried to push forward. All of this was done for one goal: to stop the process that eats the land from within. Here, soil works like a health bar in a game. If you don't restore the resource, it loses strength, cracks, and crumbles away. This process is called desertification, when living land stops regenerating and turns into sand. Over just one generation, China lost millions of acres. And those aren't just numbers, but real pieces of land where nothing grows anymore. Satellite images show how the green color retreats. On the left, there's a photo from 1984. On the right, you can see what it's like today. The difference looks as if someone pressed the fast-forward degradation button. And as usual, the ones to blame are the system's players, humans. We cut down forests, let too many herds graze, wasted water like it was endless. Nature worked like a balanced machine. But someone turned off all the safety limits, and now it overheats as if overloaded. In China, they even classify types of breakdowns. Sometimes the soil is simply blown away by the wind because plants no longer hold it with their roots. Sometimes it's washed off by rain until only bare clay remains. Sometimes it suffocates from salt after bad irrigation. And somewhere it just freezes completely. The earth turns to stone and stops responding like a shut-down server. Today, a third of the country is already affected by these mechanics. Nearly 400 million people live on the edge of burnout, where every year a field might disappear forever. And all because the system can't keep up. Too many people, too few resources. China's been trying to fix this since the 1950s. Back then, the country was building cities, roads, and dams, stripping away nature's protective layer to speed up development. Forests were cut down, steppes were plowed, swamps dried up, and every new level of civilization unlocked an old problem. The land lost its vitality and sank under the sand. But even in those areas where the dunes move forward every year, the sand isn't lifeless. Beneath the surface live dozens of animal species, from tiny gerbils to fennec foxes. They dig tunnels, build nests, pull plant roots deeper in search of moisture. The layer of sand underfoot is constantly changing, sinking here, rising there, because underneath someone is always digging, carrying materials, and building. At night, thousands of tiny footprints appear on the dunes, and by morning they're gone, as if nothing ever happened. These creatures don't try to stop the desert from moving, they've just adapted to the fact that it never stands still. They live in what people are running away from. And while humans are busy making plans to halt the desert, it's long become home to those who learn to live inside it. But it's not just about China. desertification has become a global issue. Almost a quarter of Earth's surface, about 24%, is already turned into deserts and drylands. Nearly 1/6 of the world's population lives there. According to the UN, over the past century, the process hasn't just failed to slow down, it's actually sped up. Fertile soil is disappearing not in isolated spots, but across multiple continents, in Africa, Eurasia, and South America. The fastest degradation happens where rain is rare, in arid and semi-arid zones. Over the last 40 years, the planet's lost about 1/3 of all its arable land. Soils get depleted, washed away, or suffocated under layers of sand and salt. And while different countries come up with programs and projects, the overall balance remains the same. We keep losing land. Every year, humanity loses over 29 million acres. And even projects that once seemed like the answer, like the Great Green Wall, are starting to face problems. Well, sort of. Overall, the results look decent. Hundreds of acres of shifting dunes have been stabilized, and the sand no longer creeps toward villages and roads. The frequency of sandstorms across the country has also dropped by about 1/5 between 2019 and 2014. But not all scientists share this optimism. For example, a professor from Beijing Forestry University and his colleagues write that the situation is far from simple. According to their data, up to 85% of all tree plantings eventually fail. At first, the young trees look great. They grow fast, draw moisture from the soil, and everything seems under control. But then, after a few years, the process reverses. The topsoil dries out, and in search of water, the trees reach deeper and deeper, gradually draining the underground reserves. As a result, the groundwater level drops, and the roots can no longer reach the moisture below. The final dry cycle begins, and suddenly, the trees that just recently looked green and healthy start drying out and dying. So yes, large-scale tree planting campaigns happen often. Flags, speeches, and ceremonies. But after that, someone still has to take care of the trees. And for some reason, nobody does. As a result, as I already mentioned, the trees simply die. Yet some do survive, but they don't always bring benefits. They draw too much moisture from the soil, leaving less for local grasses and shrubs. The soil dries up, loses nutrients, and a new wave of degradation begins. If there are more trees than the land can feed, sooner or later, you guessed it, yes, they die. Plus, trees create dense shade. Under such a canopy, there's barely any sunlight. As a result, grasses and shrubs underneath can't grow properly, and bingo, they die too. In the end, the soil is once again left bare and begins to erode in the wind. It turns into a vicious cycle. The trees that were meant to save the land from erosion end up speeding it up. Due to this, it's hard to say whether the Great Green Wall is actually helping nature or only making things worse. Most of the areas where the planting happens are steppes and grasslands. Trees don't naturally grow there, and trying to turn such lands into forests often only makes them even drier. Basically, instead of restoring forests where they truly belong, the project is trying to force them to grow where they simply can't survive. Some American experts even call this strategy a waste of resources. But maybe there's a solution, the one we started the video with. You just need to release the right kind of animals into these new forests, the burrowing ones. If you look at it like a game, soil isn't just the texture under your feet, it's a massive system with billions of active units. About a quarter of all living biomass on the planet lives right here in the lower layers, what could be called the subsurface biome. Each class of creature has its own role and stats. Gerbils, jerboas, moles, worms, termites, and beetles act as terrain engineers. They mix the layers, open paths for moisture, process organic matter, and return nutrients back into the main cycle. Every action they take, from digging to gnawing roots, triggers a chain of effects. Higher water permeability, reduced erosion, creation of new micro-ecosystems, even local temperature shifts. All this activity forms a system known as the critical zone, the living shell of the Earth that keeps the balance between life and climate. Basically, it's the planet's global support module. Once it stops working, other stats begin to drop. Plant growth, fertility, moisture retention. The burrowing animals follow simple rules, but their impact is huge. They dig, burrow, build branching tunnels and nests, trample the surface. All that counts as small cycles of soil reformatting. These tiny actions provide bonuses to seed germination, water retention, and organic buildup. When an animal breaks through a stony layer or pushes the lower sand upward, it triggers the soil regeneration mechanics, the formation of a new layer capable of sustaining life. Even things like wildfires and carbon balance are tied to these processes. The more active the burrowing creatures are, the lower the chance of fire. They reduce dry leaf litter, keep the moisture up, and stabilize the microclimate. And when they process organic matter, they directly affect atmospheric carbon levels, carrying out a hidden but crucial planetary quest, regulating the climate. If you think of Earth as a game with billions of tiny missions, these diggers aren't just NPCs, they're the invisible infrastructure that keeps everything running. If this were a strategy game, this is the point where the player would choose units to save the lands from an advancing desert. The system is simple. The hotter and drier the landscape, the more valuable the species that can survive where others run out of survival points. In this game, gerbils and jerboas aren't just rodents, they're biome engineering units. Their action radius is small, but their endurance coefficient is high. They work slowly but steadily, digging, moving sand, leveling the surface. You won't notice their impact right away, but after several cycles, the terrain changes. The soil becomes looser, holds moisture, and stops crumbling. Gerbils are universal operators of the desert environment. They're active in warm weather, build branching tunnels, and maintain air circulation underground. They're most efficient on maps with low moisture and extreme heat. In game terms, you'd call it a passive biome stabilization effect. Wherever they live, sand loses its structure more slowly. Jerboas are the mobile subclass of the same engineers. They can't stand direct sunlight, so they're active at night. During the day, they burrow into the sand and cut their water consumption to the bare minimum, almost like an organism with an internal resource-saving function. Their fur grows lighter to reflect radiation, and each of their burrows becomes a small restoration point for the ecosystem. Together, these species work like low-level characters that hold the entire desert simulation together. They're unnoticeable, quiet, but it's them who form the basic survival mechanics of the landscape. And when a quest pops up on the map to stop the desert's advance, the system offers a simple solution. Summon these tiny engineers. They don't build walls or irrigate the land, but they slowly change the environment's parameters. In a world where temperature keeps rising and water turns into a rare resource, it's these creatures that give us a chance to reboot the balance. And the best part, there's no need to transport them anywhere. Mongolian gerbils already live in the steppes, deserts, and semi-deserts of China, Mongolia, and Russia, meaning they're practically locals. All we need is to boost their numbers and settle them in the right areas. The small five-toed jerboa also lives in China's rocky deserts, not far at all. Plus, rodents have a natural bonus. There's always plenty of them. They breed fast, spread easily. Even if some are caught and relocated, the original population won't suffer. Sounds perfect so far, right? Not quite. Even jerboas and gerbils would have a hard time surviving in this forest, because it's not really a forest. The main problem is uniformity. The Great Green Wall project relies on what's called a monoculture, meaning they plant trees of only one species. It's simpler and faster, but there's a huge downside. If disease, pests, or drought hit this artificial forest, the whole thing dies at once. Not a single tree will survive. What's worse, the chosen species often aren't even local. They're poorly adapted to the region's climate and soil. Local plants, on the other hand, could handle heat and drought, but they're barely being planted. Basically, restoring a forest isn't just about dumping a bunch of random trees in the ground and calling it a day. What matters is what trees they are, how they interact with each other, and whether they can actually survive in a specific ecosystem. Look at Germany, for example. Their forests have suffered a lot from tree diseases, and now they're trying to bring them back, but not blindly. Scientists have been experimenting for years, planting different species, mixing them, watching how they grow. It takes years, sometimes decades, to understand which trees do best, but it gives real results in the end. That's exactly how China should have done it, but the country didn't. There's another problem: location. Real natural forests aren't just trees, they're part of a vast system that works like a pump. Forests draw moisture from the oceans, create vertical air currents, help form rain, and keep the soil moist all year round. For this system to function, the forest cover needs to stretch from the coastline deep into the continent, without gaps. Now let's see where China's Green Wall actually is. It's located far from the sea, almost on the edge of the desert, thousands of miles away from ocean moisture. As a result, it simply can't affect the humid airflows coming from the sea. There's already little rainfall here, and adding more plantations might dry the land even more. Essentially, what we have is an isolated strip of trees on the edge of the Gobi. It's not connected to the natural forests that have existed here for thousands of years, which means it can't really influence the climate the way real forests do. It's just trees growing on the edge of a desert. They barely have enough water to survive. You might as well try planting trees across the whole desert. The outcome would be about the same. And as for the introduced rodents, they won't be able to stay here for long either. Experts say it outright: the forest belts planted along the Gobi Desert will eventually disappear. And when they do, everything around them will start to fall apart. Yes, we released rodents into this, well, let's call it a forest. They'll hold on for a while, live through a couple of generations, dig burrows, raise offspring, but then things will go back to how they were. When the trees start dying, the sand will move in again and the animals will just find themselves in the middle of the desert. Unless, of course, the Chinese decide to plant the trees all over again. If we had picked other animals, they probably wouldn't survive the local heat and drought. But gerbils and jerboas are tough. They're used to this kind of climate. So they'll just keep living the way they always have, digging holes, searching for seeds, surviving. Only it won't do much good. The Pinocchio still won't turn into a real boy. Into a real forest. There's still no water, and rodents won't magically make it appear. There are other risks too. The introduced rodents might not just fail to save the ecosystem, they could actually create a new problem. Since the forest is artificial, there's no real diversity among its inhabitants. There are few predators, which means no one will keep the non-predators in check. So if you release gerbils and jerboas and just leave things as they are, they'll start multiplying like crazy. To keep the balance from collapsing, you'll have to bring in their natural enemies too: big birds, foxes, snakes. Otherwise, the rodents will become too many, and that'll lead to another disaster. If you didn't know, rodents are insanely fertile. When there's food and shelter, they reproduce at a terrifying rate. That's when the problems start. They can ruin crops, raid storage, gnaw through everything in sight. Harvests fail, farmers lose money, and food becomes harder to get. Plus, rodents push out other species, taking away their resources. In farming areas, natural predators are almost gone. Humans have taken their place. Owls, snakes, mongooses, and birds of prey leave because there's nowhere suitable for them. And when predators disappear, rodents start feeling like they own the place. It all turns into a vicious circle. Fewer predators, more rodents. More rodents, fewer plants and harvests. Nature goes off balance again, only for a different reason this time. In general, healthy pastures mean having lots of different plants, fertile soil, and living microbes that help the land breathe and recover. But in our case, none of that exists to begin with. And bringing in rodents will only make things worse. If there aren't too many of them, rodents can actually be useful. In moderate numbers, they really do act like unlicensed ecological engineers, loosening the soil, helping seeds sprout, and serving as food for predators. But if there are too many of them, that's bound to happen. Don't expect anything good. Vegetation can't recover fast enough, the soil breaks down, erosion begins, the wind picks up the dry particles, and the land slowly turns into sand. Their digging and constant search for food tear the pastures apart from the inside, turning them into bare patches of dark sand. And here we are again, a desert where a forest once stood. No real pros here, because bringing in large numbers of animals could cause an epidemic that wipes out the trees even faster. One of the main problems with monocultures is the lack of diversity. Instead of living nature full of plants and animals, we end up with a uniform plantation. Such a system is vulnerable to diseases, pests, and any climate changes, droughts, floods, sudden temperature swings. Basically, one little nudge and the whole thing falls apart. Now imagine this situation. We brought in some non-native rodents, didn't check them properly, just released them into the forest, and then it turns out one of them was infected with parasites or some kind of virus. In an ordinary forest, the disease would only affect part of the trees. The rest would survive, and nature would eventually recover. But here, all the trees are of the same species. And if the pathogen happens to be dangerous for this very species, the infection will spread like a chain reaction. In the end, everything will die, and very quickly. Besides, it's already happened before. A few years ago, a certain kind of beetle hit a section of the Great Green Wall and destroyed 1 billion trees practically overnight. One type of pest and an entire region was left barren. In theory, the same kind of beetle or any other parasite could get here by accident, together with those helpful rodents that were supposed to do some good. There's a reason real forests are so resilient. They're complex, multi-layered, with plants of different ages and sizes. Old trees die, young ones take their place. It's the circle of life. Such forests have many habitats, areas with varying levels of light, moisture, and shade. Thanks to that, thousands of species live there, each with its own role. But here, everything's the opposite. One kind of tree, all the same age, no diversity at all. In theory, in 1,000 years, this place could become a real forest if trees were gradually replaced by new generations. But there's no water here, which means it just won't happen. So what do we get? Settling burrowing animals in such conditions is a waste of time and money. Everything requires resources and people. Someone has to catch the animals, check their health, then transport them, release them, and later monitor how the program goes. All this costs quite a lot, usually paid from the state budget. Maybe they could even find the money, but the program simply wouldn't have any effect. The rodents can't fix a mistake made by humans. They won't change the climate, save the forest, or make the soil more fertile. At best, nothing will change. At worst, the destruction will only speed up. Perhaps that's exactly why China never started such projects. All efforts so far have been focused on planting trees. They've been doing it for decades, finished the campaign just a year ago, and are most likely now just watching to see what comes of it. At least there are no official reports about releasing animals, and apparently none are coming anytime soon. Apparently China has learned from its mistakes and is now working to set things right, with a much smarter approach this time. In the southwest of the country, a new, smaller scale but better planned project is now unfolding. It's being overseen jointly by Conservation International and the China Center for Nature and Society. Unlike previous campaigns where they planted just one type of tree over vast areas, this time they finally decided to diversify. The project includes conifers and broadleaf trees, grasslands, and even bamboo groves. Thanks to that, almost 12,000 acres have been restored. The main feature of the project is that only native species are used. As I said before, that's damn important. Such plants are better adapted to local soil and climate, get sick less often, and don't drain water reserves. They're also paying more attention to water itself now, planting only where nature actually allows it. This approach is now seen as an example of how to restore entire landscapes properly, not just plant trees for the sake of reports and pretty photos. Even China's National Forestry and Grassland Administration seems to have gotten the message. It started cooperating with environmental organizations and is now promoting projects aimed specifically at bringing back native species. One of the first of these projects was launched in the Sichuan province, a mountainous region where the Yangtze and Dadu rivers originate. There they plan to restore more than 10,000 acres of damaged land. And it's not just plantations. The area is considered a biological hotspot, a place where rare species still survive, including the giant panda. Everything gets better when there's a panda involved. They'll be planting local trees, almond pine, China cedar, fir, spruce, poplar, and alder. The new forest is expected to absorb around 41,000 tons of greenhouse gases every year and at the same time create about 1 million man-hours of work for planting, thinning, and tending the trees as the forest matures. And yes, this time they'll actually maintain the forest instead of just dumping seedlings in the desert. Sounds like genuinely good news to me. You owe me a like. See you later.